Section 5.2. This is right triangle trig. When you're using your calculator, be careful. Make sure your calculator is in degrees if you're talking about degrees, radians if you're talking about radians. So you can go to mode, and if it's in degrees, go over to degree and push enter. And now you see that degree is highlighted. So now if I do anything, like I want the sine of 30 degrees, it'll give me what the sine of 30 degrees is. I could change the mode to radians. And now, whatever I put in now would be in radians. So I could do the sine of pi over, pi over 2. Pi divided by 2, radians. And that gives me 1. So be careful, make sure that you're in the right mode, M-O-D-E, whether it's degrees or radians when you're doing the problems. Okay? If you're in degrees, you have to be in degree mode. Radians, you have to be in radian mode. So solving right triangles. We're going to use trig to find unknown sides or angles of right triangles. And remember, in geometry, you should have learned that, you learned SOHCAHTOA. Sine is opposite over hypotenuse. And cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. There are 3 other trig functions that I have here. Cosecant, that's the reciprocal of sine. So it's hypotenuse over opposite. Cosine and secant are reciprocals, so this is hypotenuse over adjacent. And tangent and cotangent are reciprocals, so that's adjacent over opposite. And make sure we know our sides. The hypotenuse is always the one that is opposite the right angle. The adjacent side is always next to my angle, but it's not the hypotenuse. So this is adjacent to that angle, this angle right here, that's adjacent side, because it's next to it, but it's not the hypotenuse. This is my opposite side. So from right triangle, ABC shown, find the 6 trigonometric functions, rationalize denominators where necessary. So I have a triangle, and I want to find the sine of theta. Well, sine of theta is opposite over hypotenuse. So I do have an opposite side there, because here's my angle I'm talking about. So I have 4 over 12. And it reduces to 1/3. Cosine is the adjacent side, but I don't know what this adjacent side is. So you could use, to find the missing side, Pythagorean theorem. A squared plus b squared equals c squared. So 4 squared plus b squared equals 12 squared. And then take the square root of that. So I'm going to have 4 squared plus b squared is equal to 12 squared. B squared is equal to 12 squared minus 4 squared. That's what I have here. I want b, so I take the square root. And when you take square root, it's plus or minus, but since it's a side we're talking about, it can only be positive. And 144 minus 16 is 128. I can rewrite radical 128 as 8 radical 2, because 128 is 64 times 2, and the square root of 64 is 8. So it's 8 radical 2. So now I can do cosine, adjacent, 8 radical 2, over hypotenuse of 12, and then reduce it. Tangent is opposite, which is 4 over my adjacent, which was 8 radical 2. I can reduce it now or rationalize the denominator. It really doesn't matter what you're doing, but I'm going to reduce first. To rationalize the denominator, I need to multiply top and bottom by radical 2. So I end up with radical 2 over 4. Cosecant is the reciprocal of that, so instead of 4 over 12, it's 12 over 4, or 3 over 1. Reciprocal of 2 radical 2 over 3 is 3 over 2 radical 2. And then rationalize the denominator, multiply top and the bottom by radical 2. So I have 3 radical 2 on the top. And on the bottom, I have 2 times radical 2 times radical 2 gives me 4. And then if I was doing cotangent, I would not take the reciprocal of this here. I would take the reciprocal of that right there. Because then there's no rationalizing of a denominator, because this is what's going to be, the denominator is going to be on top. So that's what I would do. So you end up with 2 radical 2. Find the 6 trigonometric functions of an acute angle, theta. So the angle is less than 90 degrees. Rationalize the denominator where necessary. So if it's an acute angle, that means I'm in this first quadrant here. There's my angle, okay? Sine is opposite over hypotenuse, okay? Sorry, my opposite side of 3 and my hypotenuse of 4, and then the adjacent side squared plus 3 squared would equal 4 squared. So 4 squared minus 3 squared, and take the square root of that, will give you the adjacent side. So 4 squared is 16, minus 3 squared is 9. 16 minus 9 is 7, so it's radical 7. So my missing side here is radical 7. So now we can find the trig functions. Sine was given. Cosecants are easy then. Reciprocal. Cosine is your adjacent over my hypotenuse. The tangent is opposite over the adjacent. Rationalize the denominator. So I have 3 radical 7 over 7. Secant is a reciprocal of cosine, so it's 4 over radical 7. Rationalize the denominator, and you get 4 radical 7 over 7. And cotangent, I would do the reciprocal of 3 over radical 7, so you have radical 7 over 3. And you're done. Some special angles. A 30-degree triangle that is a right triangle has sides that have a ratio of 1, 2, radical 3. That's the ratio of the sides. Okay? And that's why they said 1 times x, 2 times x, radical 3, that's in front, times x. 60-degree triangle is really the same triangle, because this would be my 60 degrees, but I drew it over there. Opposite the 60 is x radical 3. See, opposite the 60. Opposite the 30 is 1x. Opposite the 30 is my 1x. And opposite the right angle is a hypotenuse, which is 2x. So this should make sense. When I look at these ratios, look at the numbers. This is the largest. So this is the hypotenuse. This is the smallest. So this is opposite the 30-degree angle. So the largest is always the hypotenuse. The smallest is opposite the smallest angle. So the 30, 60, 90 triangle, you just orient them different, same numbers. In a 45, 45-degree triangle, the ratio of the sides would be 1, 1, radical 2. This is largest. Ones are the smallest. These are the same, so opposite those will be the same size angles. So that's 45 degrees, that's 45 degrees. Right angle. So you need to know these. We will be using them all semester. You need to memorize them and know them. So now, let's fill this table out. Remember, 180 degrees is equal to pi radians. So if I want to convert 30 degrees to radians, that means I need radians on the top and degrees on the bottom. So this would be pi radians on the top 180 degrees on the bottom. Degrees cancel out, so I'm in radians, and 30 goes into 180 6 times. So this is pi over 6 radians. You can do the same thing for 45 degrees and get pi over 4. Do the same type of conversion for 60 degrees and get pi over 3. So degrees, 30 degrees is pi over 6 radians. 45 degrees is pi over 4 radians. And 60 degrees is pi over 3 radians. So I have a 30-degree triangle first. Right there, 30 degrees. There's my right triangle. Sine of this angle here, 30 degrees, is opposite over hypotenuse. So it's 1 over 2. The cosine is your adjacent over hypotenuse. So that's radical 3 over 2. The tangent, TOA, opposite over adjacent. So it's 1 over radical 3, which rationalize the denominator, you get radical 3 over 3. Sine and cosecant are reciprocals. Cosine and secant are reciprocals. So you have 2 over radical 3, and then rationalize the denominator, you have 2 radical 3 over 3. Cotangent and tangent are reciprocals, or you can look at adjacent over opposite and get radical 3. 45-degree triangle, right here. So when you do the 45-degree triangle, sine, opposite over hypotenuse, 1 over radical 2 is radical 2 over 2. Cosine, 1 over radical 2 is radical 2 over 2. Tangent, 1 over 1. Cosecant, radical 2 over 1. Secant, radical 2 over 1. Cotangent, 1 over 1. And 60-degree triangle. Here's my 60-degree triangle. Here's my right angle, okay? Sine, opposite over hypotenuse is radical 3 over 2. Cosine is adjacent over hypotenuse, so that's 1 over 2. Tangent, opposite over adjacent, so that gives you radical 3. Cosecant is the reciprocal of sine, so it's 2 over radical 3, but when you rationalize the denominator, you get 2 radical 3 over 3. Secant and cosine are reciprocals, and cotangent and tangent are reciprocals, so you get 1 over radical 3. Rationalize the denominator, you get radical 3 over 3. So there's the first part of the table. I could go all the way around the unit circle, though. Here's all I did. I went to 30 degrees, and I went to 45 degrees, and I went to 60 degrees. So I found out the sine of all those degrees. But I could keep going around the circle and maybe do 90 degrees or 120 degrees. Okay? There's just some of the trig functions, what they are with the special triangles. The prefix co in cosine and cotangent and cosecant stand for complement. And let me just show you, if I have some triangle here, and it's a right triangle, and let's say this angle is 20 degrees. If this angle were 20 degrees, this would be 70 degrees, because the 3 triangles, or angles in a triangle equal 180 degrees, okay? So now, if I want the sine of some angle, let me call this my theta. So if that's theta, this angle here is 90 minus theta, right? How I figured out the 70? So the sine of theta, the sine here is opposite over hypotenuse. Here's my adjacent side. Okay? So the sine of this is my opposite over hypotenuse. The cosine of this angle right here is my adjacent side, which I call is opposite over hypotenuse. So this side over hypotenuse. So hopefully you can see that they're the same. And you can do the same thing for tangent and cotangent secant and cosecant. And if I wanted, instead of 90 degrees here, I could switch this and do it in radians. Pi over 2 radians. This could be pi over 2 radians if I wanted. This could be pi over 2. And it works. And then the theta would be in radians. Okay? So given that the sine of 25 degrees is equal to 0.4226, find the cosine. Well, the sine of 25 degrees is equal to the cosine of 90 minus 25, which equals the cosine of 60. So these two are equal. So it's equal to 0.4226. And if you want to pick up your calculator and see, you can to double check. Put the sine of 25 in your calculator, the cosine of 65, and you will see that they are equal. Section 5.2, look for the homework online.